Good day, grade 7 learners. This is Supermom Z and welcome to Sci Amazing Learning Videos. Previously, we were able to describe the characteristics of sound using the concepts of wavelength, velocity, and amplitude. Today, we will explore another type of wave, visible light. Are you ready? Let's start. Most essential learning competency. The learners should be able to explain the color and intensity of light in terms of wave characteristics. Look around you. We can see everything because of light. Our sun is a natural source of light. It is a luminous source or an object capable of producing its own light. Other sources like bulbs, candles, and flashlight are artificial sources of light. Many scientists studied light. Are you familiar with them? Did you meet them in your earlier grades? Let's get to know their ideas about light. Sir Isaac Newton believed that light behaves like a particle, while Christian Huygens believed that light behaves like a wave. Another scientist, Max Planck, came up with what is now known as the dual nature of light. He explained that light can be a particle and a wave. And to complete our knowledge about the nature of light, James Clerk Maxwell proposed the electromagnetic theory of light, which claimed that visible light is an electromagnetic wave. Maxwell described light as a propagating wave of electric and magnetic fields. Light, together with other electromagnetic waves, form the electromagnetic spectrum. It shows all types of electromagnetic waves, their frequencies and wavelengths. Remember that electromagnetic waves or EM waves do not need a medium to travel, unlike mechanical waves like sound and earthquakes. Look closely at the electromagnetic spectrum and answer the following questions. What are the different waves in the EM spectrum? Right, we have radio waves, microwaves, infrared, visible light, ultraviolet, X-rays, and gamma rays. Now try to analyze which wave characteristics increase from left to right. Nice! Frequency is 1. As you can see, the frequency or number of waves at the right is higher than the frequency of waves at the left portion of the spectrum. Also, energy increases from left to right. What about which wave characteristics decrease from left to right? Good! Wavelength decreases as you go from left to right. Notice that the wavelength of gamma rays is much shorter than the wavelength of radio waves. With this in mind, how are electromagnetic waves arranged? Wonderful! They are arranged in increasing frequency and energy and decreasing wavelength. Which EM wave has the longest wavelength? Radio waves. How about the shortest wavelength? Correct. Look how much shorter gamma rays wavelength is compared to the other electromagnetic waves. Which EM wave has a higher frequency? Microwave or X-ray? You got it! X-ray. Let's talk about energy. Which EM wave has more energy? Ultraviolet or infrared? Indeed, it's ultraviolet. I guess you perfectly understand the electromagnetic spectrum. But for today's lesson, we will focus on the visible part of the spectrum, visible light or white light. Visible light is an energy that travels in electromagnetic waves. It travels in a straight path and in a vacuum has a speed of 299,792,458 meters per second. Imagine how fast that is. Just think of sunlight reaching the Earth in just 8 minutes. Cool. Sir Isaac Newton used a prism to show that light, which we ordinarily see as white, consists of different colors. Dispersion is a phenomenon in which a prism separates white light into its component colors: red, orange, yellow, green, blue, indigo, and violet, or what we commonly term as Roige. When white light enters a prism and travels slower in speed than in vacuum, color separation is observed due to variation in the frequencies and wavelengths of color lights. Let's talk about that later. Wow, such a beautiful rainbow! Can you apply what you have just learned about dispersion? Why do we see a rainbow after raining? Rainbows are produced by a combination of refraction or bending and reflection or bouncing of light. When white light enters drops of water, which serve as the prism in this case, the light is dispersed or separated into different colors. Colors of light that we see depend on the frequency and wavelength of the radiation that reaches the eye. Looking at this diagram, which color has the longest wavelength? Good. Red has the longest wavelength. Which color has the shortest wavelength? Yes, it's violet. Good job. While sunlight contains all the colors, not all colors reach the ground in the same concentration. As sunlight passes over a great distance, colors with short wavelengths are scattered in the atmosphere, while we see the longer wavelengths, yellow and red, more prominently. Now let's analyze their frequencies. Which color has higher frequency, blue or green? Nice catch. Blue has a higher frequency than green. How about energy? Which color has more energy, yellow or indigo? Right, indigo has more energy than yellow. Another characteristic of light is intensity. It is the amount of light illuminating a surface. Its unit is candela. Take note that brightness depends on the source and distance. The closer you are to the source, the brighter it is. The farther you are, the dimmer it is. In addition, when we look at the wave's amplitude, higher amplitude means higher intensity, which then means brighter light. Can you follow? Good. Did you know that light pollution is becoming an alarming problem? According to World Atlas of Night Sky Brightness, vast areas of North America, Europe, Middle East, and Asia are glowing with light. Some of the most light-polluted countries in the world are Singapore, Qatar, and Kuwait. Light pollution, or the excessive or inappropriate use of artificial light, is affecting human health and wildlife behavior. Remember to turn off lights not only to save energy, but to decrease light pollution. Now, to check if you really understand the lesson, let us evaluate your learning. It's evaluation time. Here is a list of electromagnetic waves. Try to match them with the examples given. Are you ready? Go! Did you match them all correctly? Fantastic! Now try to answer the following questions. Who proposed that light is an electromagnetic wave? Great! He is James Clerk Maxwell. Let's proceed. Which phenomenon occurs when light passing through a prism separates into colors of light? Is it A, reflection, B, dispersion, C, fusion, D, perfusion? Good, the answer is B, dispersion. You're doing well. Let's try this one. Which color has the shortest wavelength? Correct, the color violet. Which color has more energy, yellow or orange? Right, the color yellow. Finally, all of the statements are true about light intensity except A, its unit is candela. B, it is the amount of light illuminating a surface. C, it depends on the distance to the source. D, it depends on the frequency of the light wave. Great job, letter D is not true. Light intensity depends on the amplitude, not the frequency. Were you able to answer the questions correctly? Keep it up, grade 7 students. And that's all for our lesson today on visible light. Thank you for watching this Amazing episode. See you again next time. Bye!